In the hush between radar sweeps, something larger than sound slips through. A wing with no shadow. Listen closely. This is not just a plane. It is a promise the sky makes to those who command it. For more than a decade, that whisper has shaped strategy, spending, and the imagination of militaries worldwide. The B-2 Spirit, a flying wing that looks more like a silhouette than a machine, did not simply enter the sky. It changed the rules by which skies are measured. This is its story. It begins decades earlier with a radical idea: remove the tail, flatten the form, and cut the signals that betray you. The flying wing was first sketched in the 1940s by a man named Jack Northrop. Back then, it was a theory with impossible trade-offs, aerodynamic beauty that came paired with instability. Without modern computers to steady it, the design remained a dream. Fast forward to the closing chapters of the Cold War. Advances in materials science, computer control, and radar understanding converged. The need was simple and terrifying: guarantee a platform that could penetrate the most sophisticated air defenses and return. The B-2 was born from that need, not as a sculpture, but as a weaponized solution to a strategic problem. Rain beads on the runway as the matte flying wing taxis with quiet confidence, lights glinting off its edges. The mission begins before liftoff. Checklists flow, systems hum, and the aircraft settles into purpose. How does a plane vanish? The answer is twofold: shape and skin. Follow the razor-straight leading edge. Those seams and coatings are radar armor, RAM that soaks energy and dulls reflections. Every panel is tuned, every joint minimized, so sensors skim past like wind over stone. First, the shape. The B-2's silhouette eliminates vertical surfaces that reflect radar most easily. No tall tails, no abrupt angles. The flying wing scatters radar energy rather than throwing it back like a mirror. On an enemy radar, a B-2 might register as something small and distant, a blip easily dismissed. Second, the skin. Radar-absorbing materials and coatings change the game. These aren't ordinary paints. They are engineered surfaces that trap incoming radio waves and dissipate them as heat. Even vent openings, engine inlets, and edges are shaped and shielded to avoid betraying the aircraft. The result is a radar cross-section reduced to the equivalent of something insignificant: a bird, a faint glint, while the aircraft carries a payload measured in tons. But stealth is more than radar. Heat signature is another betrayer. Engines are managed, exhaust is shielded and cooled, and thermal profiles are carefully controlled so infrared sensors have less to detect. Maintaining these properties demands painstaking maintenance, specialized coatings, climate-controlled hangars, and teams of technicians who treat the aircraft as living, secretive organisms. Now imagine flying a wing with no tail. Historically, that implies unstable flight. The B-2 solves that instability not with brute structure but with brains. Its fly-by-wire system is an electronic puppeteer. Thousands of inputs per second, minute adjustments to trailing edges and control surfaces to keep the aircraft calm and steady. This is stability by computation, where software replaces mechanical complexity and makes a mammoth airframe behave like a precise instrument. High above weather, the wing barely flexes. Stability comes from code, constant micro-adjustments that hold a perfect line. It flies like a calm instrument, translating turbulence into quiet, predictable motion. Inside the cockpit, there are only two people. Two pilots do what entire crews used to do: manage long missions, complex systems, and the psychological weight of hours spent inside a near-invisible delivery platform. Training is intense. Pilots must be comfortable trusting algorithms, interpreting sensor feeds that often show nothing, and making decisions with global consequences. Under red lights, the crew briefs with ritual focus. Roles lock in, contingencies reviewed, and timelines synced. Every voice short, every checklist exact, because precision on the ground buys freedom in the air. Hands steady on throttles, eyes forward, the cockpit glows. Minimal symbology, maximum discipline. The mission lives in muscle memory: scan, confirm, execute, while the world outside remains deliberately unaware. Payload and Reach define the B-2's operational identity. It can carry up to 20 tons of munitions, nuclear or conventional, and with aerial refueling, its reach becomes almost limitless. From U.S. bases, with mid-air refueling, the B-2 can project force anywhere on the planet. That global reach turned it into more than an aircraft. It became a tool of deterrence and a lever for precision power projection. Across dark water under stars, the wing cruises in long, silent arcs. Distance folds under endurance. Deterrence isn't loud, it's the quiet certainty that reach and precision can arrive unseen. Strategically, the B-2 was born to assure a second strike. During the Cold War, nations needed credible ways to respond if struck first. The B-2's ability to slip past advanced defenses bolstered the survivability of nuclear forces. But deterrence is a political instrument as much as a military one. A weapon that can be counted on to penetrate defenses changes calculations at a diplomatic level. It shapes doctrine, treaties, and the very budgets of national security. Yet none of this comes cheap. Approximately $2 billion per aircraft, a number that stings when printed as a single-line item. But that figure hides layers of cost. Research and development stretching decades, highly classified supply chains, bespoke manufacturing, and maintenance regimes more akin to medical care than routine servicing. Only 21 were built. Rarity multiplies cost and mystique. For some, the price is justified by the strategic insurance it buys. For others, it reads as an extravagance in a world of proliferating alternatives. Real missions prove the concept. The B-2 has been used in real combat operations, slipping into defended airspace to deliver precise strikes. But real missions expose weaknesses too. The logistics of operating from distant bases, the vulnerability of support networks, and the diplomatic exposure when a secretive mission becomes public. One loss, one captured component, or one publicized failure can ripple politically as much as militarily. The B-2's legacy is not only in combat reports. It forced engineers and strategists to rethink aircraft design. Material science labs learned how to make surfaces that interact with electromagnetic waves. Control engineers push the limits of stability augmentation. Maintenance crews learn new rituals for preserving stealth. In a sense, the program pulled forward entire industrial capabilities that later migrated to other platforms. Technological change is relentless. Enter the B-21 Raider, a next-generation design conceived to learn from the B-2's strengths and weaknesses. The Raider's brief is practical: preserve stealthy performance but reduce unit cost, increase producibility, and simplify sustainment. Where the B-2 was almost artisanal in how it was built and maintained, the B-21 represents industrialized stealth. It acknowledges that future conflicts require numbers, not just showpiece singulars. Abstract grids and sensor overlays resolve into meaning: targets, routes, emissions, threats. Industrialized stealth pairs with industrialized data, fuse, filter, and forecast in real time to stay one step ahead. But what if the rules of detection change? Imagine a radar or sensor suite that can see through current stealth techniques. Or consider offensive cyber attacks that manipulate flight systems mid-mission. These are not science fiction. The arms race between stealth and detection is continuous. Each advantage breeds new counters. It means investments in stealth must be paired with investments in electronic warfare, defensive coding, and operational flexibility. On a tablet, the mission flexes mid-flight. Spectrum shifts, routes pivot, decoys deploy. Agility is survival, electronic warfare, code updates, and tactics that rewrite themselves while the aircraft remains unseen. Beyond machines, there is a human dimension. Sitting in that cockpit for hours demands focus, endurance, and judgment. There is a psychological load in being the vector of so much destructive potential. The decision to press release is not only technical, it's moral. Pilots train to compartmentalize, to execute mission parameters, and to survive in a world where choices reverberate far beyond immediate objectives. Breath slows, grip relaxes. Micro inputs keep needles centered while hours stretch. Fatigue is managed like fuel, scheduled, measured, and countered, so judgment stays sharp when timing matters most. Pre-dawn edges the horizon, instruments glow faintly. The body wants rest, the mission wants exactness. Sunrise brings weather, tankers, windows, and decisions. Another phase line crossed cleanly. Consider cost versus utility from the policy table. Governments weigh the strategic value of guaranteed penetration against other investments: satellites, cyber capabilities, ballistic missiles, or unmanned systems. The B-2 offers a unique blend of stealth, precision, and human command. Its rarity gives it prestige and deterrent effect. Yet the question is perennial. Does a handful of exquisite platforms deliver better returns than a larger fleet of more expendable systems? The answer shifts with doctrine, threat perceptions, and budgets. In combat scenarios, the B-2's combination of range and payload enables missions impossible for other platforms. Hardened bunkers can be targeted. Leadership nodes in depth can be struck. Yet these missions require a supporting cast: tankers, electronic warfare assets, intelligence feeds, and diplomatic cover. A B-2 strike is rarely a solitary act. It is the apex of a complex choreography. Turn, egress, and fade. Radios compress to essentials. Emission control tightens, and the aircraft melts back into background noise. Exfiltration is as deliberate as entry, measured, patient, and quiet. Let us imagine alternate futures. In one, detection tech advances to render current stealth techniques obsolete. The world shifts toward active defenses and rapid distributed weapons. The role of penetration platforms diminishes. Emphasis moves to standoff capabilities, cyber means, and massed unmanned systems. In another future, stealth evolves. Materials and active signature management keep pace, and penetration platforms remain central. Or a hybrid emerges. Stealth harder to achieve, but combined with autonomous systems and distributed logistics, making operations more resilient. Senior leaders weigh options across dashboards, risk curves, escalation ladders, and timing windows. Capability is leverage, but judgment is policy, balancing speed against stability, message against effect. Factories retool while software updates ripple across fleets. Stealth is not static. It's a moving target maintained by code, materials, and logistics that iterate in lockstep with threats. The aircraft's maintenance and industrial footprint are a quiet battlefield. The B-2's skin, that radar-absorbing armor, is fragile by design and demanding in care. Hangars keep the fleet in controlled environments. Technicians in protective suits apply coatings like conservators restoring masterpieces. This industrial choreography is expensive, time-consuming, and sensitive. It also creates dependencies, a supply chain that, if disrupted, reduces the platform's readiness. Readiness graphs dip, recover, and stabilize as parts flow and crews cycle. The quiet battle is uptime, predictive maintenance, protected supply chains, and the discipline to keep secrets flightworthy. From an engineering perspective, the B-2 taught the world that design philosophies can be resurrected. The flying wing, once impractical, became practical through computation and materials. The lesson extends beyond aircraft. Decades-old concepts can be revived with new enablers, whether in robots, networks, or energy systems. Across decades, ideas shake hands. What once failed for lack of tools now thrives with computation and composites. The flying wing returned not by luck, but by new instruments enabling an old vision. Politically, the B-2 operates as a symbol and a tool. It reassures allies and complicates an adversary's calculus. Its very existence alters negotiations, arms talks, and the psychology of deterrence. A platform that can get through defenses is as much about belief as hardware. Adversaries must factor the possibility into their strategies, even if they never see it. As a closing thought, the B-2 story is incomplete without the B-21 and the next waves of innovation. The Raider aims to institutionalize stealth, design it for mass production, not museum exclusivity. That shift recognizes the changing economics of warfare, where scale and sustainment increasingly matter. The B-2 remains an engineering milestone, a wing with no shadow, living proof that stealth is a product of shape, surface, and software. It rewrote design rules, pushed materials labs into new territories, and reframed strategic thinking about deterrence and precision power projection. History will record its successes and its costs. Yet perhaps the most enduring lesson is broader. When technological constraints fall, ideas long dismissed can return, refashioned and formidable. The flying wing was not an accident. It was an idea waiting for its time. So when you next look up and imagine a whisper across the clouds, remember, the sky keeps secrets, but humanity builds them. The B-2 is one of those secrets made real. A machine of shadow and science whose implications go far beyond metal and paint, into politics, industry, and the shape of future conflict. This is the story of a wing that chose to disappear and, in doing so, force the world to change how it sees danger, defense, and the very meaning of visibility. A wing without a shadow reshaped how nations plan, negotiate, and fight. Shape, surface, and software turned absence into advantage, and secrecy into strategy. The lesson is durable. When technology removes constraints, dismissed ideas return, sharpened. Stealth is not invisibility, it is probability, managed relentlessly across physics, code, and people. The B-2 proved the model, the B-21 scales it. As detection evolves, so will countermeasures, and the dialogue between them will define the next era. What you cannot easily see can still change everything.